Hello everybody, this is Mustafa Javadian. I'm a PhD student in hydrology. Today I'm gonna present a recent study that is global trends in evapotranspiration dominated by increases across large cropland regions. This is a collaborative work of me, Dr. Ali Berhangi, Dr. William Smith from University of Arizona, and Dr. Josh Fisher from NASA JPL. Along with the increasing global temperature, evidence from the change of precipitation, runoff, and soil moisture suggests that the hydrological cycle has been intensified in many regions of the world during the past decades. As the only connecting component between water balance and energy balance, and due to the complex interactions between soil, water, vegetation, and atmosphere, actual ET is perhaps the most complicated component of the hydrological cycle. Actually, it is important for irrigation scheduling and developing water use efficiency in agricultural areas due to the significant relationship between soil water depletion and the evapotranspiration rate. Therefore, investigating actual eating croplands is crucial both at local and global scales. The aim of this study is to investigate the global ET trends in croplands and their relationships with other variables. First, we wanna see is there any significant trend of actual ET in the entire globe. Then we investigate the trends in croplands. Our next question is how can we introduce an index to give a warning about the AET trend of croplands. Then we like to see what is the status of each country in this analysis. And finally, we will explore the trends in major croplands. Our datasets are shown in this table. For actual ET and potential ET, we used MODIS ET product. MODIS AET product is based on the Bellman-Modis equation, which includes inputs of daily meteorological analysis data along with MODIS data products like vegetation, albedo, and land cover. The MODIS PET product utilizes Priestley-Taylor expression. The flowchart shows our workflow for this study. Here we start with 8-day AET and PET product along with monthly precipitation to calculate the annual trends for each variable. Using MODIS land cover, we also calculate the trends on croplands. Then we will use these trends values to answer our scientific question that I mentioned earlier. In this study, we used 10 terabyte data without downloading a single file. We used Google Earth Engine cloud computation platform to perform all of our analysis. The annual trend of AET, PET, and PP in millimeter per year are demonstrated in left figure. The most significant increasing trend in AET are located in Central Asia, South America, Southern Africa, and Eastern Asia. In contrast, North high latitudes and the Amazon rainforest show a decreasing trend in AET, which might be related to decreasing in PP and deforestation respectively. It also shows a significant decrease in PET over wide regions in the tropics and Central Asia. On the other hand, an increasing trend in PET is observed over Europe and Central America. Precipitation trends shows that precipitation is increasing in the Amazon rainforest and the Southeastern Asia. The mean global annual values of AET, PET, and PP demonstrate that there is no significant trend in the mean global AET and PET over land between 2001 and 2018, which is shown in right figure. In contrast, the precipitation has increased to 4 mm per year during this time period, which is not significant. We further focused our trend analysis on croplands due to their importance for food production. The trends of AET, PET, and PP in croplands were calculated, which is shown in this figure. For croplands, the average global mean of AET and PET are 2 and 5 times more than that calculated over the entire global lands respectively. While there is no significant trend in croplands, PET, and PP, actual ET demonstrated a significant increasing trend during the last 18 years studied here. AET of the global croplands has increased by 3.5 mm per year, which is equal to 14% much larger than the AET trend of the natural land. Here there is an important question. How can we talk about ET trends? Is increasing actual ET favorable or not? Actually, we cannot answer this question without looking at potential ET and precipitation. Therefore, in this study, we introduce a new index based on a combination of AET, PET, and PP trends to determine the sustainability of actual ET trends with respect to climate condition in each pixel. This index, titled the Evapotranspiration Warning Index (ETWI), is described in this slide. The more negative values of ETWI means the more non-sustainable AET of croplands, which is an index of water use croplands. In other words, the more negative values of ETWI gives us a warning in terms of water use of that cropland because the changes of PET and PP were not enough to compensate for the increasing trend in actuality. ETWI was applied to croplands to consider the combined effect of these variables. The average value of ETWI for the global croplands is -0.4, suggesting that the changes in PET and PP trends are not enough to compensate for the large increasing trend in AET. Croplands water management mainly depends on the internal rules of countries, and also climate change can affect countries' cropland differently. Therefore, the trends in croplands and ETWI were averaged in each country and compared. Most of the countries except those in Southeast Asia and a few others show an increasing AET trend in croplands. Among those, Brazil has the largest AET trends. For PET, most African and South American countries show a decreasing trend, while European countries demonstrate an increasing trend. India and Southeast Asia countries show the largest positive trends in precipitation for their croplands. By neglecting countries with low agricultural activities, the overstressed countries in the non-sustainable trend of AET in croplands are Thailand, Brazil, and China. On the other hand, Senegal, Benin, India, and Pakistan show the most sustainable trend in AET of croplands. Interestingly, developing countries have better conditions than developed countries in terms of the sustainable trend of AET in croplands. One may expect that trends may not be the same for different crop types. Here we use a 9-kilometer dataset and sharpen the map by applying threshold to retain grids that mostly contain major crops to avoid large uncertainties in this result. The global major croplands map is shown here. The time series of mean annual values of PP, PET, and AET for those major croplands are demonstrated here. Based on this figure, rain-fed rice lands are mainly located in high precipitation areas with more than 1650 mm annual rainfall, which makes sense due to the high need for water for growing rice crops. The AET trends in all major crops are significantly positive. In this case, rain-fed and irrigated maize show a more increasing trend. Surprisingly, most of the major crops demonstrate a decrease in their PET at this time period. Irrigated wheat has a minimum negative trend value than others. Additionally, most of the major crops except rain-fed rice experience an increasing trend in their precipitation. By combining all these variables in ETWI, irrigated maize experienced the most non-sustainable trend in actual ET. SIF can be used as an index of crop productivity. The question is whether non-sustainable increase of water use in cropland results in higher productivity or not. The SIF annual trend is shown here. According to this figure, Southeast Asia and Europe have experienced an increasing trend in SIF. In contrast, SIF in some parts of Central Asia, Southwest US, and South Africa have decreased during 2001 and 2017. Correlation analysis shows that in croplands, the AET trend doesn't necessarily follow the PET trend with a correlation equal to -0.2. In other words, irrigation planning has likely done with little or no consideration for change in climate. As expected, the trends of SIF trends and AET shows high correlation in cropland. Interestingly, ETWI, which is an index of sustainability in water using croplands, doesn't have a significant relationship with SIF trend. According to this result, we can somehow conclude that a non-sustainable increasing trend in AET croplands may not increase crop productivity in long term. In other words, increasing water consumption in long term without considering the climate doesn't necessarily increase the crop yield. In this study, which was entirely done by Google Earth Engine, we developed a user-friendly evapotranspiration trend monitoring application that enables users to produce annual Etm App for any user-selected year. Furthermore, users can obtain annual trend of AET, PET, and PP and GPP trend as well as monthly PP trend for any user-selected grid. The user interface of the Etm app is shown in this figure. User can search for a location at the top of the app in any language. The user is also able to select a year to display its annual actual ET map. By selecting any point on the map, the charts for the selected pixel will appear in the left panel. User can also save any chart for the selected pixel in CSV, SVG, and PNG format. As a conclusion, our results show that while ET has not significantly changed in natural land, it has significantly increased across croplands in the last 2 decades. We also showed that continued increases in croplands ET and in turn croplands productivity are likely unsustainable based on regional water balance calculations. And finally, we present an online user-friendly application designed to enable near real-time monitoring and improved understanding of global ET dynamics. For those of you who are interested in detail of our work, this study has been published in a remote sensing journal and you can check it out online. Thank you. Thank the University of Arizona Earth Dynamic Observatory for funding this study, and thank you for your attention. Please feel free to reach out if you have any questions. Thank you.